Unit 7, Video Lecture 2, Balancing Chemical Equations. We've already discussed word equations that tell us what are present in a chemical reaction. We talked about skeleton equations, which give us the basis for doing our chemical reaction. We use our formulas in place of the names. The third type of chemical reaction is going to be a balanced chemical reaction. So in order to do this, what we're going to do is we're going to make sure that the number of atoms and the number of atoms in the product are the same. If we have more reactants than we do products, then we won't balance. If we have more products than reactants, then we won't balance. So we want the right number of atoms in the reactants and the same number in the products. In order to change the number of reactants and products, we're going to put numbers in these open spaces. Those numbers are going to be called coefficients. Coefficients are going to change the number of atoms that we have. So, for example, if we have NaCl, this formula unit is made up of 1 sodium and 1 chlorine. If we put a coefficient like 2 in front of it, then that 2 says that there are 2 things of sodium and 2 things of chlorine. Essentially, it says that we have 2 formula units of NaCl. If we look at water, H2O, right now we have the 1 oxygen that's bonded to the 2 hydrogens. If we put a 3 out in front of it, that means that we have 3 molecules of water. That 3 distributed to the H2, we have 1, 2, 3, 4, 5, 6 hydrogens The 3 is also distributed to the O, and we have 1, 2, 3 oxygens. If we look at copper 2 nitrate, now copper 2 nitrate says that we have copper that's bonded to NO3, NO3. If we were to put a coefficient in front of it, it means we would have 2 things of CuNO3 too. So this 2 is distributed to the copper. There's our 1, 2 coppers. But this 2 also is distributed here. So we have 1, 2, 3, 4 nitrogens. Essentially, we're taking, in our NO3, we're taking the subscript for nitrogen, which is a 1, multiplying it by the subscript that's outside of the parentheses, and then further multiplying it by the coefficient. So 4 nitrogens. So for oxygen, we've got 3 oxygens here, 6 oxygens, 9 oxygens, 12 oxygens. So considering our formula, and we'll move up here away from everything else, our coefficient 2, so we take our coefficient 3 and multiply it by we take our subscript 3 and multiply it by our subscript that's attached on the outside. We then are going to take into account our coefficient. So we have 2 times 3 times 2, so that's 12 oxygens. Let's practice another one like this. If we had Al NO3 2, and let's say we had 3 formula units of this. Well, we have the 3 aluminums. We then, if we're going to consider nitrogen, if we're going to consider our nitrogen, there's 1 nitrogen here, so nitrogen is going to equal the subscript times the subscript on the outside of the parentheses times the coefficient. So we're going to have 6 nitrogens. If we're going to, let's consider the oxygen. So we're going to take the 3 oxygen atoms that are present and multiply it by 2, and then take 3 molecules. So this compound, there's going to be 18 atoms of oxygen. Let's take another compound. Let's take Ca CO3 and let's say that we have 3 formula units. Well, our elements that we have present, we have calcium, we have carbon, and we have oxygen. So here we take our coefficient 3 and multiply it by the subscript of calcium. So there's only 1, so that means that I have 3 atoms, I have 3 calciums in that compound. I now take that 3 and multiply it by the subscript for carbon, the 1 carbon times 3. But I also have 2 of those, so I'll multiply that by 2. So this gives me 6 carbons. For oxygen, I have 3 atoms of oxygen already. So I'll take 3 and multiply it by the subscript, and then multiply that by the coefficient. This gives me 18 oxygens. So I'm going to make use of these coefficients and our ability to count atoms to balance our equation. So if we look at our equation that we've been working with, iron plus chlorine yields iron 3 chloride. My elements that are present are iron and chlorine. In my reactant side, I have 1 iron and 2 chlorines. In my product side, the subscript for iron is 1, so I have 1 iron. So we are balanced here. But chlorine has 3. So what we've done is we've first counted the number of atoms in the skeleton equation. When it's not balanced. So the first element that's not balanced we're going to add a coefficient. So, if I put a 2 out here because I need more chlorine, I no longer have 2 atoms of chlorine. I have 2 times 2. So I have 4 things of chlorine. Well, now I have more chlorine in the reactant side than I do in the product side. So I'll add a 2 here. Remember, this 2 is distributed to both the iron and the chlorine. So now I have 2 times 1, so I have 2 things of iron. And where I had 3 atoms, I now have 2 sets of those 3. So that means that I have 6 total atoms. So, since I need more chlorine, I'll change the 2 and make it a 3. So that 3, and I have 2 atoms of chlorine in that molecule. So I have 6 total atoms. 6 atoms, 6 atoms. So what we did is we kept changing the numbers until we got an equal number of atoms. And then the last step is going to be to continue for each element. So, my chlorines are balanced, but now I have 1 to 2 irons. So if I put a 2 out here, I now have 2 things of iron, 2 and 2. So my balanced equation is 2 Fe plus 3 Cl2s yields 2 FeCl3s. Let's look at another one. Magnesium plus oxygen yields MgO. So as of right now, I have 1 magnesium because the subscript for magnesium is 1, and I have 2 oxygens. In my products, I have 1 magnesium and 1 oxygen. So, I need oxygen on the right side. So I'll put a 2 in front. That 2 is distributed to magnesium and to oxygen. So now I have 2 things of magnesium and 2 things of oxygen. Well, I'm balanced here, so I'm okay now. But I need magnesium. So to do that, I'll put the coefficient here. Now I have 2 magnesiums. So 2 magnesiums on the left side, 2 magnesiums on the right side. Our equation's balanced. Let's look at an equation with some polyatomic ions. So here, our first substance is calcium. This is our first element. Now, NO3 is a polyatomic ion. If the polyatomic ion travels to both sides of the equation, if it's in the reactants and the products, count the polyatomic ion as a single entity. So count the polyatomic ion as a single thing. But we can only do this if it appears on both sides. So, we have our calcium. We have nitrate because it's on both sides. The next thing we have is sodium. And then again, another polyatomic ion, PO4. Does PO4 travel to both sides? Since it does, we can count PO4 as a single thing. So we've identified our atoms. Now we're going to count atoms. The coefficient here, or the subscript here, is 1, so we have 1 calcium. The 2 tells us that we have 2 nitrates. Subscript 3 tells us that we have 3 sodiums. And here, PO4, it's not in parentheses, it's all by itself, so there's only 1 PO4. In the product side, 3 calciums, 2 PO4s. In sodium nitrate, there's only 1 nitrate and only 1 sodium. So now we can start to balance. Our first element that's unbalanced is calcium. We have 3 in the product side, and we have 1 in the reactant side. So, if I put a 3 in front of the calcium nitrate here, that 3 will go to calcium, and I can have 3 calcium atoms. Calcium is balanced. But remember that that 3 doesn't just go to calcium, it goes to the nitrates. So, since there are 2 nitrates already, we take that 2 times 3, and now we have 6 nitrates. If we want to look at this another way, here's calcium, 1 nitrate, 2 nitrates, 3 nitrates. If I were to have 3 formula units of that, I'd have 1, 2, 3 calciums, oh, well, I guess I lost it. So, the next thing I need to balance is my nitrate. I have 6 nitrates in the reactant side and only 1 on the product side. So I'll put a 6 in front of the sodium nitrate. This changes both the sodium and the nitrate. So instead of having 1 of each of these, I now have 6 my nitrates are balanced. The next element in our table is sodium. Here, in the product side, I have 6 sodiums. In the reactant side, I only have 3. So, if I put a 2 out in front of the sodium, where originally I had 3, I now have 2 of those molecules, or I have 2 of those formula units. So I have 6 sodiums. That balances sodium. But remember, this 2 also goes to the PO4. I used to have just one thing of PO4. Now I have 2. So if I look at this again, I had Ca3, PO4, 2, let's look at another example. Nitrogen plus hydrogen yields ammonia. Well, my substances are nitrogen and hydrogen. In my reactants, the 2 tells me that I have 2 nitrogens, and the subscript 2 tells me that I have 2 hydrogens. In ammonia, there's only 1 nitrogen, but there are 3 hydrogens. So, the first thing that's unbalanced is nitrogen. I have 2 in the reactants, and I have 1 in the products. So if I put a 2 out front, I now have 2 nitrogens in the products. So nitrogen balances. But remember, this 2 also goes to the hydrogen. So I originally had 3, and now I have 2 things that have 3 hydrogens. So that means that I have 6 total. So to balance hydrogen, I take a look. I need something times 2 that will give me 6. So if I put a 3 here, 3 times 2 will give me 6. 6 hydrogens in the reactants, 6 hydrogens in the products. Let's take a look at another one. H3PO4 plus HCl yields PCl5 plus H2O. This one's slightly more difficult. If we look, our first element is hydrogen. Our next element is a polyatomic, PO4. But when we look, there is no PO4 in the products. Since there's no PO4, we have to separate our polyatomic into P and O. In our next compound, we already have hydrogen, but then we have chlorine. So there's our table. Step number 2 is to start counting our atoms. We have 3 hydrogens here and 1 hydrogen here, meaning that we have a total of 4. We have 1 phosphorus in the PO4. We have 4 oxygens and 1 chlorine. In the product side, we have 1 phosphorus, 5 chlorines, 2 hydrogens, and 1 oxygen. Now, if I were to give you a piece of advice here, I would tell you that whenever you're balancing, I would suggest leave hydrogen last. Leave hydrogen last and balance your other elements in the equation. Let's take a look. If we skip hydrogen for right now and compare and go straight to phosphorus, we have one phosphorus in the reactants and one in the products. So phosphorus is balanced. If I want to balance my oxygens, I have 4 oxygens in the reactants and 1 in the products. So to balance it, I'll put a 4 in front of H2O. That means that I now have 4 oxygen atoms. But remember, that 4 is also distributed to the hydrogen. So where I first had 2, I now have 2 times 4, or 8 oxygens. Or 8 hydrogens, sorry. But now, my oxygens are balanced. And finally, my chlorines. I have 5 chlorines in the product side, but only 1 chlorine in the reactant side. So to add more chlorine, I put a 5 in front of the HCl. The 5 times the 1 chlorine that's already there gives me 5 chlorines, which balances it. But recall that the 5 is also distributed to the hydrogen. So, in my first compound, I have 3 hydrogens, and now in my second compound, I have 5 hydrogens. This gives me a total of 8 hydrogens in the reactants. So by leaving hydrogen to last, it's taking care of itself. Go ahead and pause the video lecture and try this. Six lithium, 1 sodium, and 2 lithium nitrates. How about this? What about this last one?